let's jump into what we're going to start today. So today we're going to look at measurement, and we're just going to sort of slowly get into it by looking at the theorem of Pythagoras. So I know quite a few of you will have actually done Pythagoras in class already, so don't stress. We're just going to see, for those of you who haven't, I'm going to explain it, and we're going to go through some questions of them together. Okay, so basically the Pythagoras theorem is a rule that we can use when we are dealing with right-angled triangles. Okay, and it's all about the relationship between the three sides. Remember, when we're talking about a side, we're talking about the outside. So that's a side, this is a side, and that's a side. Okay, those are my sides of my triangle. When we're dealing with Pythagoras, we need to know a few important words. So the one important word is we need to understand what this little square is over here. So can someone tell me what that little square is? What is that little square? A right angle, exactly. Okay, so when we see that square in a shape, it is a right angle, and exactly, Tracy, right angle means that it is 90 degrees. Okay, so that's what that little square means. Then we have another important thing when it comes to right angle triangles. We've got this line over here. Who knows what that line over there is called? Something we've been talking about in similarity. Yes, there we go. Oh, and even spelt right. Well done. It is the hypotenuse. Okay, so hypotenuse. The hypotenuse is the longest side of a right angled triangle. Okay. And it is always the side that is opposite the right angle. So wherever we have a right angle, it will be the one that's opposite. So if I draw a little triangle like this, and there's my right angle, then this would be my hypotenuse. Okay, so it's always going to be the side that is opposite our right angle. That's going to be our hypotenuse. All right. Does anyone have questions about this? Or feeling confused? All good. Okay. Cool. Comfort. Yeah. How can I help?
Ma'am, the hypotenuse, it is always the line that... Ma'am?
Yes, I can hear you now.
Yeah, I also lost contact a little bit.
Ma'am, the hypotenuse is the line that you have drawn, like the imaginary line.
So it's a real line. So the hypotenuse is the longest side of the triangle. So like this over here would be my hypotenuse. If I drew another triangle like this, well, let's do it looking slightly different. Let's say that was my triangle. Okay, then my hypotenuse would be that line over there.
Oh, okay, ma'am.
So it's always going to be that longest one in the triangle.
Yes, ma'am. Thank you.
Okay, no problem. Okay, so that is basically just that. That's what we can use. Yes, it is. Roro-san for the question that just came in. Okay, so Pythagoras' theorem uses this idea of squares. Okay, and basically his idea was that this area over here, so this green area, if I worked out that area, it would be equal to the area of this blue square plus the area of this red square over here. Okay, so if I'm wanting to work out the area of a square, so like, let's just look at this red square to start. If I just wanted to find the area of this red square, how would I find the area of that red square? How would I find the area of this red square that I've highlighted? Bruce, yes, how would I find its area?
Ma'am, by calculating C and B.
Okay, but if I didn't have any other information, if I just had this red square, just that red one, how would I work out its area?
Ma'am, you'd have to use the 90-degree angle.
So think about, how do you work out, if I gave you a square that looked like this, okay, and I said that this was 4 and this was 4, how would you work out that area in there?
I'm lost, ma'am.
That's okay. That's okay. Let's see if someone can help out. Yes, my heart. How can I work out the area of this red square if each side was 4?
I don't know if it's convenient, but then I think we say like 4 squared.
Good, exactly. Yes, that's 100% right. If I wanted to find out this area of this red square, I would say that that's 4 squared, which is 16. That's 100% right. Perfect. Okay. So if I'm wanting to find the area of this red square down here, and I know that my one side is A, then the area of my red square is going to be A squared. Okay. And if I wanted to find the area of this blue square over here, then my area would be B squared. And if I wanted to find the area of this green square over here, then this would be C squared. And then just keep this the same. So Pythagoras' theorem is saying that if we take our blue one and we add our red one, we would get the same number as our green one. So his theorem is saying that if we had B squared, okay, B squared, and we added C squared, A squared, we would get C squared. This is Pythagoras' theorem. That's all it stands for. Okay, so this is what it looks like if you were to see it as a visual. Obviously, when we're working with triangles, we're not seeing these big squares that are attached to all of our sides. But this is where the actual theorem originated from. He said, if I had a square that was built on the same side as my hypotenuse, its area would be equal to the area of the other two squares. Okay, what this actually means for us when we're trying to work this out is that we've got a side over here, which is A. Don't panic, don't panic. We've got a side over here, which is B, and we've got a side over here, which is C, and C happens to be our hypotenuse. Okay, so if we're trying to figure out how we could write this for like ourselves to make our lives like nice and easy, all we're doing for Pythagoras' theorem is we are saying our side 1 squared plus our side 2 squared is equal to our hypotenuse squared. That's all Pythagoras is saying. Exactly, Marcus, it's exactly the same thing. So your one side squared plus your other side squared is equal to your hypotenuse squared. That's exactly what we're seeing here. We're seeing B squared plus A squared is equal to C squared. Yes, no, Lihle, you'll absolutely be given numbers. This is just actually understanding where Pythagoras came from, like where the theorem like originates from, why it makes sense. Don't stress, it's really not a hard concept. I just wanted you to actually visualize what it is so you're not just learning something off by heart. You can sort of see some of the reasoning behind it. This is the idea of what the Pythagoras theorem looks like. Okay, don't stress. We haven't gotten into any of the examples the way that they'll be asked in class just yet. So don't panic. Okay, so this just is very basic idea of what our Pythagoras is. We take our one side squared plus our other side squared, and that is equal to our hypotenuse squared. That's the whole idea of Pythagoras. Okay, if you want to take a screenshot of this, you're welcome to, and then we're going to go into our very first example so that you'll see how nice and easy this is. You will need your calculators today, so please can you go and grab them? If you don't have them, go grab them now. So Sonia, the formula stays the same always. It's always going to be one side squared plus the other side squared is equal to the hypotenuse squared, but we can manipulate it sometimes to make our life easier, which I'll show you, but you can also just keep it, you can keep it as happily as you like. No, you could put a squared first. You could say a squared plus b squared equals c squared. You could also say, c squared equals a squared plus b squared. All the same. Okay, let's have a look. This is what it would look like. So we would be given a triangle, and we have to the first thing we have to do, and I recommend you get your highlighters out while we get used to this, is highlight your hypotenuse. Okay, so we want to highlight our hypotenuse. Our hypotenuse is the one which is always going to be opposite our right angle. Okay, so we always want to know which our hypotenuse is, because the hypotenuse squared is equal to the sum of the other two sides squared. Okay, so what I mean by that is x squared, that's my hypotenuse squared. Let's just write this out. That's my hypotenuse squared. Okay. And that is equal to, and then let's take our different sides. We've got this side over here, which is 4 squared. And then we've got this side over here, that's 3 plus 3 squared. What you're seeing here is the sum of the other two sides. Some of the squares. The other two sides. Okay. Now in maths, whenever we make a statement like this, we have to give a reason. Okay, so we're going to make our statement. We're going to say x squared is equal to 4 squared plus 3 squared, and then we have to give our reason. And in this case, our reason is Pythagoras. Okay. Dirbocho, I see your hand. I'm just going to finish this example, and then I promise I'll come to you. Okay. From here, there are lots of quick ways to go about this, but I'm just going to show you the long way while we're getting used to it. You can put this straight into your calculator. So you can say x squared is equal to 16 plus 9. X squared is equal to 25. And then we would have to square root both sides. So x is going to equal 5. Done. So Tristan, it's an interesting question. They actually recently changed the rule in the matric paper that you couldn't write Pythag anymore, that you had to write Pythagoras. I think that change happened last year. So I don't know how strict they're being with it yet, but you may want to get into the habit of writing Pythagoras. Okay, Didvoho, how can I help?
Ma'am, I wanted to know, where do you get the square?
Where do we get this? The squares that we're putting on the numbers?
Yes.
That's part of the Pythagoras theorem. So his whole theorem is that if we take this side and we square it, and we take this side and we square it, it's going to be equal to this side squared.
Oh, okay.
And so that's why we're putting in those squares.
Okay.
Okay. Belinda, how can I help?
Hi, ma'am.
Hi.
So I am very confused because at school we do it like way differently.
Okay, tell me how you've done it at school, and then we'll see if we can try and find a middle ground.
They say that like in the test, we had to always start with a squared plus b squared equals c squared.
Okay, so
or we won't even get a mark.
Okay, the problem with that is we don't have an A, B, or C on this triangle. Do they want you to write? So like if you were given a picture like this, would you still have to write a squared plus b squared equals c squared?
Yes, because they said, I think because it's Pythagoras, it's the Pythagoras theorem, and you have to like start with it, and then you like figure out your A and B. So if I'm going to say like a squared plus b squared equals c squared, then under it I'll say 4 to the power 2 plus 3 to the power 2 equals x squared, and then I'll carry on until I get my answer.
Okay. That's fine. It's fine. I want you to do what your school wants you to do. I'm not going to write that first line of a squared plus b squared equals c squared because it doesn't make sense to me when it's not on the triangle. Okay. But what I will do is I will rewrite how I'm writing the sentence so that it looks more like what you're used to, so that it seems a little bit scarier, less scary. So, okay. And then I think we can try and find a middle ground behind it. But that is bizarre that you are needing to do that at school. But it's okay. It's okay. I feel like there must be a good reason behind it. But yes. Okay. Akka, how can I help?
Ma'am, I just want to ask, how did it get to the 5? Like the answer, how did it get there?
So we square rooted the x squared to get x, and so we square rooted the 25, so we get 5. Oh, I've lost you. Hopefully that made sense though. Mamelo, how can I help?
Ma'am, I wanted to ask the same question.
Okay, excellent, good. Sarah Lee.
No, ma'am, it's okay because I understand it now. We just did it a different way in our book, but now I understand it.
Okay, no problem.
Not confused anymore. Thank you.
Okay. Nolan Wabo, how can I help?
Ma'am, can I ask a question? How did we get, okay, I see that you said 16 plus 9, but then when you say 25 divided by 2, it says 12.5.
So we're not dividing by 2. So this isn't 2x, it's x squared. And so the opposite of x squared is to square root something. And so we are square rooting the 25. We're not dividing it by 2.
Oh, okay.
Okay.
Thank you.
All right. Guys, the hands that are up at the moment, I'm going to go through the next example. And then if you still have that same question over the next example, then just pop your hands up again for me. Okay. I just want us to sort of be able to see a second one here, but don't panic. I will come back to your hands if you still have it in the next one. All right. You're also welcome to write these questions in the chat and we will get to them. Okay. So this is exactly the same. So let's have a look here. What we've got is this over here is our hypotenuse. Okay, that's the side that we're thinking. So if I'm writing this similarly to how some of you are doing it at school, I would say 5 squared plus 12 squared is equal to x squared. And my reason would be Pythagoras. Okay, so if you're at school and you have to write a squared plus b squared plus c equals c squared, that would just be the line above that. Then we can go straight into our calculators. So we can say 5 squared is 25. Okay, 12 squared is 144. And that is equal to x squared. 25 plus 144 gives us 169. And that is equal to x squared. And so if I want to know what x is by itself, I'm going to square root both of these. And I'm going to see that, oh, wrong color. I'm going to see that x is equal to 13. And I should actually write 13 centimeters. Okay. If anyone had a question in the last question that I didn't get to and you're still feeling a little bit confused, please pop your hand up. That's totally fine. Kamahelo, if this is the way that you feel more comfortable with, just write it like this. It's exactly the same as this. It's just written on the other side of the equal sign. Cool. Okay. Yes. Naledi, how can I help?
Ma'am, the way we learned it in class is a bit different. I just wanted to confirm, like, okay, ma'am, so can we use the first example as
Sure.
or what I want to show you? Okay,
Sure.
ma'am, so on the top right, on the top angle, ma'am, can you please write A?
Like as in for the triangle.
Yes, ma'am. Okay, so ma'am, the teacher said that instead of saying A, B, or C, we would say A, B, and then plus BC equals, and then it would say AC. And then, ma'am, the formula that we would use, it would say 1/2 times B times H. Is that the same thing to what we're doing right now?
No. Okay, so, okay. 1/2 times B times H is if we are wanting to find the area of this.
Oh, okay.
Totally different formula. If you have these ABCs like this, you absolutely are welcome to write that first sentence the way that sort of it looks like some of your other schools are also asking you to. So saying AB squared plus BC squared equals AC squared Pythagoras. And then going into this line over here, totally fine to write that as a beginning line. It's not necessary as you move up in school, but if it's something that your school wants you to do, then please feel free to do it. Kamachelo, that is weird. We always write our statements in our, we always put our reason after our first statement. I'm not sure why they are telling you to do that. Kira?
Hi, ma'am. Can you hear me?
Hi, I can.
Ma'am, at school, like we do it like a longer method, ma'am. Like we do it like I'm gonna give an example. For example, df squared equals fe squared plus de squared, and then like we go like that, ma'am. Like, but
Okay,
like
so
this is way different to what we do in
that's
school, ma'am.
That's what I just wrote here, though.
I didn't say, sorry.
Okay. So what I was saying was you can absolutely write it that way if you want to. 100% you can. It's not necessary as you move up through school, but if your schools are wanting you to do it, then please write that as your first sentence. Okay, Tatendo.
Ma'am, I just wanted to ask, because since I came late, I'm not quite sure yet. So I wanted to ask, how do we always get x squared at the end of?
Okay, so x squared is our hypotenuse. I think what I recommend though, Tatenda, if you arrive late and that's where the confusion's coming from, I think the best suggestion is to watch this video from the beginning again, because I can't explain it just because you were late. But I think go through the lesson and you'll be able to see where we're coming from. And otherwise it'll start piecing together as we go through our next lesson. Next example. Lunico?
Ma'am, I wanted to ask, where does the centimeter come in?
It's because they are units, and these are 5 centimeters and 12 centimeters. So this would be 13 centimeters.
Oh, okay, ma'am. Thank you.
Okay, no problem. Mamelo?
Ma'am, may I please ask, on the first example, where you wrote x2 is equal to 2 minus 5, why did you write 2 minus 5 instead of 25?
I didn't write 2 minus 5. I did write 25.
Oh, okay, ma'am.
All right. I feel like I need the brain break, Princess, to be honest. Let's move on. Okay, let's have a look over here. So the reason we don't have to put the reason down here when we find x is because we've put our reason over here. So think about it like when you deal with any kind of geometry question, whenever you write your statement, you always give your reason straight after your statement. So this is the same idea. This is our statement. That's our statement. The same way we've learned in geometry. That's our statement. And that's our reason. And so we write our statements and then we write our reason and then we just solve for x. Same. Okay. So now these ones are slightly different. And I'd love to know if someone can tell me what makes this one a little bit different to the ones we were just doing. Yes, Nomaza, please tell me what makes this one a bit different.
They've already given us our hypotenuse.
Yes, good. They've given us our hypotenuse. Okay, so Nomaza, if you had to write this as a sentence, so like thinking about how we wrote these statements over here, how would I write C as a statement?
You'd say 10 squared is equal to 8 squared plus x squared, and then write Pythagoras as your reason.
Perfect. X squared plus 8 squared is equal to 10 squared Pythagoras. Beautiful. 100%. Okay, so all that's happened here is our unknown is not our hypotenuse. They have given us our hypotenuse. And remember, our hypotenuse is always the one that's all by itself on the other side. So we've done the same thing. We've just said our one side squared plus our other side squared is equal to our hypotenuse squared. Then we have to start working things out. So we would say, okay, x squared plus 64 is equal to 100. Where would I go to from there? Where would I go to from this point over here, where I've got x squared plus 64 equals 100? So Asande, it would be wrong to say given. We only use given when we're dealing with similarity and congruency. generally, if in like a geometry situation, we always have to give another reason. Chikondi, can you tell me where I'd go to from here in this equation?
Ma'am, so you
Yeah.
take the 64 over 200, and then you're gonna say 100 minus 64.
Beautiful. And what does that give me?
36.
Glorious. Okay, where would I go to from here?
And then you're gonna square root the 36.
Yes. And so what is x going to be equal to?
X is equal to 6.
X is equal to 6. Beautiful, 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 beautiful. So we really just have to, okay, so Naman, sometimes we have to find the hypotenuse, sometimes we don't. So like in this example, we weren't finding the hypotenuse. We were just finding another side. But basically with Pythagoras, so if we have a right angled triangle, as long as we have two sides, we can always find our third side. And sometimes that third side is a normal side, and sometimes that third side is the hypotenuse. Yeah. Okay. Give it your best go. I want you all to give D a try by yourselves. I'm going to give you a couple of minutes to try it, to make sure you can get through the whole thing. It's not going to be, oh, let me not ruin anything just yet. So give it your best go. Make sure you've written everything out. Make sure you have your reasons and you've set it out in a good way. And then we can talk about it. I think Unati is wanting to answer this one. That's what I'm assuming that hand is. Unati, if I'm wrong and it's a question, let me know in the chat.
You guys are doing great.
No, I'm not wrong. Yeah.
Now they will
I figured.
understand. More
Yeah.
examples are yet to come, and then you guys will understand that Pythagoras is like the nicest thing ever.
Yeah, Pythagoras is our friend. It's our friend.
Yeah.
Okay. I'm going to give you guys 30 more seconds. Yeah, decimals are 100% okay, Princess. General rule with decimals is rounded off to 2 decimal places. Unless you've been told otherwise in your test. You're most welcome. Okay. Unati, talk me through.
Hi, ma'am.
Hi.
So, ma'am, what I wrote is that I said 7 squared equals to 1 squared plus x squared. Pythagoras.
Perfect. Thank you.
Ma'am, but is it fine if I write pi, not the whole thing?
You got to write the whole thing.
Ma'am, but at school they said that you don't have to.
Yeah, but in matric, you won't get the mark if you don't write the whole thing.
Okay, ma'am.
So you can, I mean, like, obviously, if you're wanting to take the shortcut while you can write Pythag because you're not going to lose a mark in school. As long as you trust your brain enough that when you get to matric, you will remember to write Pythagoras.
Ma'am, and then the next step is 49 equals to 1 plus x squared.
Okay, beautiful.
And then you take the 1 over, so it's going to be 49 minus 1, which gives you 48.
Good. Perfect.
And then you square root. So x is equal to 6,9.
Can you give me 2 decimal places?
Ma'am, would I say 6,93?
Yes, yay, well done. Nice job, Unati. Okay, so if we were looking at this, guys, if we were looking at this as a decimal, we would see that we would have 9, let's just write it like this, we would have 6, 9, 2, 8, 2, oh gosh, 6, 9, 2, 8, 2, blah, 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 okay? And if we wanted it to go to 2 decimal places, then we only care about these two. But that 8 that is sitting next to the 2, that's going to make the 2 go up. So our final answer is going to be 6,93. Then we need to be careful with our units. We're working in millimeters. So we're going to say millimeters is equal to x. And that would be our final answer. If your order is wrong. So this order doesn't matter, guys. Like however you write this is fine. This first line over here, as long as you've only got the 7 squared on one side alone, then it's fine. Like you could 100% have written this as 1 squared plus x squared equals 7 squared, or you could have written it as x squared plus 1 squared equals 7 squared, or any of those. As long as the 1 is by its, like the 7 squared is by itself, it's okay. So depending on your school, generally 2 to 3 marks, depending on how hard it is. Okay. Princess, how can I help? Oh, Princess, I'm so sorry. We can't hear you. It might be a headphone situation. Try and unplug in and replug them in again. Or write your question in the chat for us. Cecil, how can I help?
Ma'am, I have a question. So in my school, they said they don't mind if you like, okay, for example, I said x squared is equal to 7 squared minus 1 squared. I didn't put the 7 alone. I was asking if you could get that wrong, if you did it like how I did.
That's 100% fine to have written it like that.
Okay, ma'am, thank you.
No problem. Lihle, how can I help?
Afternoon, ma'am.
Afternoon.
Ma'am, I just wanted to ask, in the second line, ma'am, the 1, it doesn't have to the power of 2. What happened to that?
So 1 times 1 is just 1. So 1 squared is 1.
Oh, okay. Yes, ma'am.
Okay.
Thank you,
No
ma'am.
problem. Okay. Akka, how can I help?
Ma'am, I got the wrong answer on the second last line, the square root of 48. I only got 3 square root, something like that, ma'am.
Okay, so you would have gotten this. You would have gotten that x is equal to 4, like looks like that, right?
Yes, ma'am.
Okay, so this is third form. It's the same answer, it's just not in decimal form. So on your calculator, you need to push this button over here that says S to D. And that S to D button is meaning third to decimal. That's what that means. And then it'll give you your decimal answer. Okay. Okay, I think let's quickly go down, do a very short brain break, and then we'll pop back up and see how things go. But I think we're just going to do one of the questions in our brain break today. Okay, quick brain break, and then we will jump back into some Pythagoras. All right, so your question for today is this. I want to know what the question mark is.
We can do this by pen. Let's rob a bank, guys.
No. I haven't seen the... Tumelo, nice job, man. Tumelo, do you want to explain how you got your answer? Do you want to pop your hand up for me? No, you're always shy to talk. But yes, your answer here was definitely 32 for those of you who managed to get there. Oh gosh, the pen is very excited with life. 32. Let's see. Kira, can you explain to us how it's 32?
Ma'am, yes, I can. Ma'am, we had to because we had to double it 16 times 2, and then I got 32. That's what I did.
How did you know that you have to do 16 times 2?
Because 3 plus 1, and then it's 3 plus 1 is 4, and then I said 4 times 2 is 8, and then it's 6 times 2 is 12, and then 16 times 2 is 32. That's how I did
There
it.
we go. Yeah, that's perfect. That's great. 100%. You could have also looked at it the other way. So 4 times 2 is 8. This way is exactly the same. So 3 times 2 is 6. 8 times 2 is 16. 12 times 2 is 24. So you're just multiplying them by 2. That's all. We do have another brain break, but I think it might take a little bit too long. So what I'm going to do with our second brain break is I'm going to give you a time limit for it. And if we have someone who gets the right answer in that time, then that will be great. I'm just trying to get a timer happening on my phone over here. And if we don't have someone who gets it in that time, then I'll bring it back in our lesson on Thursday. I'm going to give you exactly 1 minute. Okay. I'm setting the timer. And go. I hope you can see the timer.
The whole vibe where you even bring your phone so that they can see that the time is ticking.
Ticking. Ticking. I haven't seen the right answer yet, though. Ah! Yes! No, man! Nice job! 30 seconds to go.
And delay also got it.
Ah, nice, nice, nice. Yes, well done for those of you who got it. The answer was indeed 8. So it was looking at basically you would have to do the same thing to everything in order to get that middle number. So 16 minus 8 would give us 8. 10 minus 2 gives us 8. 12 minus 4 gives us 8. 9 minus 1 gives us 8. So all of them would give us 8 if we subtracted one from the other. And that was our little brain break. Yeah, well done. You got that quickly. I really was worried that we weren't going to get it in time. Just saw the diagram and gave up. Alvarez. Okay, let's jump into some questions here. Okay, so I want you guys to try and do this one by yourselves now, because now you have enough information in order to do it. This is the way these types of questions would be asked in a test or in an exam. Okay, so this is saying an ant is walking from point B to C to D to E and finally to F. Okay, so we've got like a little ant is walking along that road. And we want to know the length of its route. So I want to know how long that yellow line that I've highlighted is. Now, in order to do that, you're going to have to work out 2 different things. And then you're going to have to do some adding. So in total, this question, I'm going to give you, what am I going to give you for this question? I'm going to give you 8 marks for this question. I'm going to give you 8 marks for this question. Let's see who can get close to that 8-mark goal. Let's have a look. Just give it your best go. Put your thinking hats on. Get your calculators out. Make sure you're feeling comfortable with your work. And then we can go through it together. Yeah, just keep going, guys. Keep putting in the time. You'll get there. Try and put into effect everything that we've learned now. Okay, we've got some answers coming in. They are 2 different from each other. So it's a good thing. We're trying different things. Oh, Nati looks like she is ready to answer. see. Guys, just a reminder that if you're feeling that the pace in this foundation class is too slow for you, remember that there is the standard class that starts and runs from 6 until 7. And so if you're feeling like this is too slow, you just need to just send Yolanda a direct message if you can. She'll have a look at it now. And we can follow up on that and see if maybe moving to the 6 p.m. class is a better move for you. Okay.
Yep. My babes, I'll be here waiting for those messages.
So just send them her way. Okay. Let's have a look. All right. Nati, can you talk me through the first half of this?
Ma'am, only the half.
First half, and then I'm going to ask Namaza to help us with the second half.
Okay, ma'am. So what I first did, I started with the top triangle. So I said FE squared equals to DE squared plus FD squared.
Okay.
Pythagoras.
Thank you. All right. Next line.
And then I said x squared equals to 2 squared plus 4 squared.
Okay.
And then, ma'am, can I just continue saying x squared?
You can. So unless you write x on the diagram, you can't use x. But if you wrote x on your diagram, that's fine. But that's the reason I'm saying FE squared.
Okay, ma'am. So you're gonna say FE squared equals to 4 plus 16.
Good.
And then FE squared is gonna equal to 20. And you're gonna square root. And I got x equal to 4,47 centimeters.
Perfect. Perfect. 100%. Thank you very, 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 very much. Okay. Now, Mother, you're going to talk us through the second half of this. So far we have FE.
Okay, slay. I said, well, 15 squared is equal to 9 squared plus x squared.
Okay, so
but in this case, it's going to be BC squared.
Yeah, so if you write an x there, you can say x squared, but otherwise we're going to use the side that it's been given, and then we need to give our reason.
Pythagoras.
Okay, cool. Next.
Then I just worked out 15 squared and 9 squared, which is going to be 250 if I'm not mistaken.
So are you asking what 15 squared is?
Not necessarily. I'm just checking.
So 15 squared is 225.
Then it's wrong.
Okay. Oh no, we've taken a turn.
Oh my gosh. Okay, no. But thanks.
Do you think you can talk
okay,
me
now
through
my
from here
first
with the
row.
numbers that are on the board?
Oh, sure, ma'am. You would take 81 and bring
Okay.
it over to the other side, and it'd be
Yeah.
225 minus 81
Good.
equals to BC squared.
Mm-hmm.
Sure, ma'am. I haven't worked this one out yet.
That's
But
fine.
it would be
That
that
would be
one
144 is equal to BC squared.
equals to BC squared. Then after
Yeah.
that, you'd square root it to
Good,
get
so
rid of
which is
your squared on the BC.
perfect. Okay.
Then after that, you get 12.
Okay.
Slay.
Nice. Naledi, can you help us wrap this all up?
Ma'am, actually, I have a question.
Okay.
Ma'am, in the first part of the question, where the answer is FE equals 4.47 centimeters. Ma'am, I wrote 4.48 centimeters. Is it okay?
So square root of 20 gives us 4.472. So because the third number is 2 and it's not 5 or above, then that second number needs to be 7, not 8.
Okay, thank you, ma'am.
Okay. Okay, let's wrap this up. So what we have at the moment, we have FE, which is 4.47. We've got DE, which is 2. We've got DC, which is 9. And we've got BC, which is 12. And all we have to do now is add up those sides. So the journey of our ant, I'm just going to write it over here. Our ant is going 4.47 plus 2 plus 9 plus 12. So 4,47 plus 2 plus 9 plus 12, and that gives us a total of 27,47 centimeters. That would be our journey of our ant. Okay, if you've done this on your side to give yourselves marks, I want you to give yourselves a mark for one of those lines, depending on how you've done it with the reason, okay? And then a line for your working out and a line for your answer. And then the same idea here, working out answer, and then 2 for your ant's journey. And see how you did out of 8 here. Nice. Nice job, guys. Solid work. So this is the way these types of questions are asked in Pythagoras. It's sort of just like applying what we use Pythagoras to help us answer different questions. Okay. I think, and then let's just do one. Oh, so if you want to take a screenshot, please feel free to take one. And then we're going to do one quick one, which I think I might need to talk you through, just because our time's running out. But I'll give you a minute to have a look at it first and see if someone is feeling brave who thinks that they could talk me through what I could do here. Lunati, I see you feeling brave.
Okay, ma'am. So firstly, you would say 125 squared.
Let me just get a slightly thinner pen. Yeah, 125 squared.
Ma'am, and then would you put the 2x in a bracket, then you put the squared?
Good, you would absolutely put it in a bracket. Good.
Plus x squared.
Good, and then?
Then, wait, 125 squared. 15,625.
125 squared is going to give us 15625, yeah. And that's going to equal what?
Ma'am, and then would you times the 2 inside the bracket?
Yeah, that square needs to go into both of them. So what would 2 squared be?
Ma'am, 4.
Good, okay, and x
squared.
Good, good, okay, plus x squared, cool. What would my next line look like?
Ma'am, would you divide by the x squared on both sides?
What can I do with those two sides? What are those two things? What are they?
Ma'am, they're like terms.
Yes. And what do we do?
You can add.
Good. Okay. Okay. So let's add them together. What would we get?
5x squared.
Good. Okay. Now where do we go?
Ma'am, you divide by 5 on both sides.
Good.
Then can I quickly calculate?
Absolutely, you can.
Ma'am, I got 3,125.
Good. Okay, where do we go to from there?
Ma'am, and then you're going to square root.
Good, good. And so what will my answer be?
55,90.
Good. Nice job. Well done for coming up to the challenge. Excellent work. Okay, so this is like a slightly trickier question and a different way that they can ask a Pythagoras question. They really like to bring in the idea of algebra with Pythagoras because it makes you have to think in a slightly different way. And so this is quite a good example of this. One of the reasons teachers love questions like this so much is that a very common mistake is people will write 2x squared and they don't square the 2. They only square the x. So having that bracket around the 2x is really important, and it's why questions like this like to come in, because they know they're trying to trick you.